Okay, let's measure this flame concentrations using a method to capture the gas sample from the flame and able to get a good benzene signal. So here we have this active scan actively running right now, and it shows a previous run, and we can get an experiment started and get good timing to inject this sample right as the next run is ready. So let's do the next sample in timing with this one. So we have about 6 minutes remaining for the next sample to be available, or 6 plus some cooling down time. Okay, so the procedure starts with a freshly evacuated, right now a vacuum pump is emptying out this cylinder to vacuum to remove its the previous flame sample and removing the cooling water that was used to cool it down, as you will see shortly. Okay, so let's remove the sample cylinder that's freshly prepared. Turn off this pump here. Get this sample cylinder ready to be mounted into the sampling line. So that is orientated like this. And by the way, this sample cylinder has a heating tape to heat it up, as we'll see shortly, to desorb benzene, and it's insulating here. So we're going to mount it like so. So that's into the sampling line where the flame is going to be burned on this burner stabilized flame, and nitrogen is going to dilute from a cross flow as the sample is getting cooled. Okay, so let's turn on these pressure gauges where this pre-mixed flame is set up along with the dilution line. So here's the sampling nitrogen set at 1.8 liters per minute. Now I'm going to open up this evacuated tank. So that opens up the line to the opens up the sample cylinder to the flame gas. So I'm going to turn on the sampling vacuum pump. That's going to balance out the sampling pressure between the flame and the sampling line, and I'm going to open it up at slightly positive pressure, so that the flame doesn't immediately start filling the sample doesn't immediately start filling it up until the flame has settled out a little bit. So I'm going to open up the flame line gases and double check that the pressures are set to the calibration. That's pretty good. I'm going to go ahead and ignite with the torch here. Okay, the flame is ignited, and visually it looks okay. The spacing is good. I'm going to set this suction to negative so that it gives negative 20 millimeters of water. When that settled, I started timing on my watch here 45 seconds. That 45 seconds is going to allow the flame gases to flush through the sample cylinder, and what is probably effectively coating benzene, the walls with benzene, because benzene is happily gas phase in the flame, but as soon as you extract it to lower temperatures, it condenses, and it's necessary to pretty much collect it on the walls for the most part. And the next stage, we're going to show what we do to capture that signal after we get a sample cylinder. So this 45 seconds is running up. I'm going to close this manometer to protect that, and then I'm going to capture the sample. So there, by doing that, we capture the sample. Turn the flame off. Okay, I'm turning his off so that it doesn't happily turns off in a safe manner here. Okay, flame's dead. Now we're ready to detach the sample cylinder and get it ready for injection. So here, we're going to take this off and take it to the gas chromatograph, mass spectrometer system, gas inlets. Okay, that thing fell off, that's okay. So it's going to go in this direction, mounted onto this nice ring stand here. That's clamped down. I'm going to take the 2 leads. This is a heating tape powered by this controller, this temperature controller here. And interestingly enough, once those are connected, I'm gonna start heating it up to 150 Celsius on this PID controller here. And I'm gonna start timing 4 minutes of bakage. And I'm gonna mount this temperature feedback here. And this is not necessarily, this feedback temperature controller, it's not expected to reach 150, but it's gonna keep on, the controller's gonna keep on giving it full power as long as the feedback temperature is less than 150. And after 4 minutes, I'm gonna go to the next phase. Okay, so while that is baking for 4 minutes, now's the time to get the next sample cylinder ready. Here, a previous sample cylinder is under the cooling station here, where under full flow, it's having cooling water flow through the chilled wall water from the lab. So I'm gonna turn this off and disconnect it and empty out the water. So that's disconnected, turned off. Now, disconnect this and then take it to the sink to empty out this accumulated water. All right, cut. Okay, the water's emptying out. Let's go to the next station over here. This, while the sample is running or not running, the helium is flowing through to keep the sample line clean, and that's running here on this helium. I turned this off to prepare it for the flame sample to go in, and this is the previous line. I'm going to dry it out with this flow of argon for a little bit. I'll let this run for about a minute or so. Now we're going back to this timer. We still have about a minute and a half, and it's time so that this previous run that just finished is gonna be, as soon as this run is ready to go from the previous run, we can start the next one in pretty efficient timing. So we'll get this started. It's gonna be at the 8mm sampling height. Get that ready to go. This next sample won't be ready to run until that's 45 Celsius, the starting condition. And in the meantime, this cylinder is still baking to desorb, to do two things. When we collected this flame sample from the flame, it was at negative pressure so that we can suck from the atmospheric pressure flame. So the result is a negative pressure tank with benzene sample in there, probably attached to the wall. So by baking it for 4 minutes, we do two things. We bring the cylinder from negative pressure to positive pressure, and it desorbs all the benzene that was collected from the flame so that it can go into the gas phase and flow into the detector. So hopefully we see a strong benzene signal. And as this is finishing desorbing, what I'm going to do is turn this heaters off. As you see, it heated up a little bit. So based on the placement, it's probably much hotter than the plate where the thermocouple is reading. But so now I turn it off, and I'm going to disconnect the helium flushing line. This is helium flushing, and attach the flame sample. Turn off that alarm because I'm doing this connecting the tank now. I'm going to open up the tank and allow it to flush through for 2 minutes. And as expected, thankfully, the tank is strongly pushing the flame sample through the line because it's hot enough to go from negative to positive pressure, and hopefully it's hot enough to absorb all the benzene to the wall. And that timing is going to be good so that in 2 minutes time, this will be ready to start another scan. So now this is pretty much done, where we took a flame sample, are feeding it into the GCMS, and during this time we can prepare the next tank, which has some drying from this flow of gas, and then get evacuated from the vacuum as we started off the previous run. So this is going to make sure that the flame sample is over from the previous run and remove any excess water that was in there. So this sample is getting pushed through for 2 minutes because it takes time for the gas sample to fill the sample loops and fill enough to represent, instead of the flushing helium that was cleaning it out before, to switch that over with the flame gas in a sufficient amount in the sampling lines to then get fed to the detectors. So it's going to be, it's flushing, filling the flame sample to both detectors. Both column 1 and column 2 sample loops are getting filled up. And then when the sample is ready to go in 20 seconds, the temperature is ready, the timing is almost ready, it's going to switch into these 2 columns. So we got about 10 more seconds, and everything looks good in this procedure. We got a new sample ready. After the cooling cycle was allowing it to cool down much faster than it would otherwise. Now that this is allowing me to start the run, I can start run. And success, we will truly know success in about 2.3 minutes, where we expect to see a benzene signal from this sampling part here. Okay, with that, we'll go ahead and wait for this benzene signal. Now that this sample, we waited 30 seconds for this sample to fill up. Now that this 30 seconds is filling up the sample loops into the columns is over, we're going to go ahead and dismount this by removing the power for the heating tanks. This is off, so that's good. Take off the thermocouple, dismount the sampling. Old sample cylinder. It's hot because it's been baking by the heating tapes for 4 minutes, and I'm going to bring it over to the cooling station. So in 10 minutes time or so, this is going to be ready to get dried out for the next sampling run, because if we didn't do this cooling step, it'll take much longer to reach the atmospheric temperature, because this heating baking step won't work if it's not cold, because you need this delta T to get the delta P. All right, so that's running. So now we're basically can connect back this helium. So now that the sample is done, we can run helium through to clean the sampling line, because our flame sample has a lot of condensables that over time will probably start to collect on the sampling line, so the helium helps to flush it out. And what we're waiting for is at 2.3 minutes, we expect to see a decent benzene signal, which is the hardest signal to get on this measurement because of the condensable nature of the benzene itself. So that was a success. Let's double check here. Yeah, we see this little signal. That all of this is necessary to get this signal here, and it's quantifiable and reproducible using this method of basically desorbing from the walls.